Okay, so we're going to be looking at angles, exterior angles of polygons. So what I want you to do is hit pause, make some notes, get the lesson objective, heading and keywords down, then write start or underline, and when you're ready, hit play again. Okay. Okay, here are three questions for the starter. It's been amazing, the starters, because pupils you're all starting to produce some wonderful answers. Pretty much perfect. It's almost as if people aren't pressing pause and having a go themselves, because their solutions that I've been seeing in the last couple of days have been perfect, but I know you wouldn't do that. So now it's time to hit pause, have a go, and when you're ready we'll go through it together. Okay, good. Now I know you've had a go. Let's go through this together. So let x be equal to 0.34, recurring. In the first instance, I'm going to multiply x both sides by 10, so 10x is equal to 3.4, recurring. Call that equation 1. And then I'm going to multiply x by 100 this time. Well, I'll multiply both sides by 100. That gives me 34.444, recurring. That's my second equation. Now, to get rid of the decimals, I'm going to subtract 1 from 2. That's going to give me 90x. Oops, let's draw a line underneath it. 90x is equal to 34 take away 3, 31, which means that I'm going to take the 90 down below the 31, so x is equal to 31 divided by 90. Here, I'm looking for the square root of 72 as a surd. I can't see it straight away, but I know that 12 times 6 will give me 72. 12 is got a square number in it. 4 times 3. Oh, hang on. 6 is 3 times 2. So I've got 4 and 9 there, which is 36 times 2, which is 72. That works. Square root of 72 is square root of 36 times square root of 2, which is 6 root 2. And finally, I'm going to multiply what's inside the brackets by what's outside. So multiply both terms by root 3. Root 3 times root 3 will give me 3. And root 3 times minus root 2 is minus the square root of 6. Right, what I want you to do is to mark your work and then rag rate it, and then put a comment so I can see how you found this, comfortable with surds, happy proving that a number is rational. Oops, we didn't say that then. Therefore, 0.34 recurring is rational. Okay, and then when you're ready, hit play again, and we're going to look at exterior angles. Right, so we're looking at exterior angles of polygons. We've been looking at interior angles. We were looking at interior angles yesterday. There we go. And we were finding out that the interior angles of a triangle are 180 degrees, and it depends on how many triangles we can fit inside the polygon. That will tell us how many degrees the angles add up to. This one we could fit 2, and in this pentagon we could fit 3. Now we're going to look at the exterior angles of a polygon, the blue dots. Now, because the blue dots and the black dots are on a line, they're going to add up to 180 degrees. Okay. It doesn't matter where they fall, they're on a straight line, so they both add up to 180 degrees. Now, you could print off one of the attached sheets. It's got these diagrams on them, and if you measure the exterior angles and add them together, you'll find that they sum up to 360 degrees. So the exterior angles of any polygon sums up to 360 degrees. It's a really useful fact to have, because you know that any polygon you're given will sum up, the exterior angles will sum up to 360 degrees. I've got this GIF which I'm going to play for you now. That'll show you why they sum up to 360. Right, so with this GIF, essentially the sum of the exterior angles of these shapes is a triangle, quadrilateral, pentagon and hexagon. They sum up to 360. It doesn't matter which shape it is, the exterior angles will always sum up to 360, because if you shrink the shape and you get them all together, they become the angles at a point, and the angles at a point always add up and there. So each one is shrunk to a point, and angles in a circle or angles at a point add up to 360. So that's why the angles, the exterior angles of any polygon sums up to 360 degrees. Okay, good. Right, so let's have a look at some regular polygons. It's important we use regular to help us to see what's going on. So we've got our triangle, quadrilateral, which is a square, pentagon, six-sided shape, hexagon, eight-sided shape, octagon. Okay. So if we look at the exterior angles on the triangle, because there are three exterior angles, we know they sum up to 360, so if we divide by 3, we can work out each one, 120. With a square, you're already aware that the interior angles are 90, and we know that the angles on a straight line add up to 180. So the four exterior angles are going to be 90 each. But we can work that out by doing 360 divided by 4, because there are 4 of them. That gives us 90. And so on. So with the pentagon, we've got 5 angles, 5 exterior angles. So if we do 360 divided by 5, gives us 72. So each exterior angle in the pentagon is 72. And I think you get the general gist. Hexagon has still got 6 angles, 6 exterior angles. Because it's a regular shape, they're all going to be the same. So 360 divided by 6 is 60. Okay. And with 8, it would be 360 divided by 8, which is 45. So what I want you to do, oops, you didn't see that then. We're going to work out the exterior angles in these shapes here. So I want to work out W in the first one. So how am I going to do that? I know that the 3 of them add up to 360. So I'm going to do 125 plus the 90 there. I know it's 90 because it's put a square there. When I add these two together, I get 5, 1 carry 1, it's 215. And then to work out W, I do 360 minus 215. And that gives me W. I need to borrow from the 6, goes down to 5. 10 take away 5 is 5, 5 take 1 is 4, and 3 take away 2 is 1. So W equals 145 degrees. What I want you to do now is to work out X on 2, Y on 3, and Z on 4. So hit pause, have a go, and when you're ready, hit play again. Remember, they all add up to 360 degrees. Okay, so let's go through your workings on this question here, question number 2. Whoops. We should have the exterior angles are 88, 115, and 108. When we add those together, we should be getting 311. And if we do 360 minus 311, that gives us X, which is 49. So X equals 49. This one, question 3. I hope you've been careful because it causes confusion if people have been looking. So 90 is an exterior angle. 125 is an interior angle. If you look at it there, that's 125. So exterior is going to be 180 minus 125, which is 55 degrees. So now I can add my exterior angles. I got 55, 80, 65 and 90. If I add those together, that gives me 290 degrees. And I take that away from 360, I'm left with 70 degrees. So y equals 70 degrees. So minus there. And it's a similar story on this one. Just got to be careful checking that they're exterior, because that 58 is an interior angle. If I take that away from 180, I get 122 degrees. So if I add my exterior and take it away from 360, you should be getting z equal to 36. But I'll check that in your workings. Okay. So, I've got a few questions for you to work through. 4 questions. Hit pause now. Have a go. I've attached this sheet, this worksheet, to the bottom of the assignment, so you can print it off if you would like, or you can just do them in your book. So, hit pause. Have a go. When you're ready to go through the solutions, hit play again. But I'll keenly be looking at your answers in your work you hand in. Right, go. And now I want you to check your answers. There you go. So on question 1 you should have 140, on 2 55, on 3 69, and on 4 119 degrees. Okay, for classwork, start at question 4. You got a mix of questions, and then you got some fluency questions, which move into problem solving. So good luck, enjoy.